Okay, we're going to start talking about the basic elements of consumer theory, how the consumer makes his decision between how much he values a bundle of goods and how much he can afford it. Okay, so we're going to take a very graphic approach at this time, and we're going to start off with what we call a commodity space. It's just a fancy sounding word for geometric space or graphs where every point within the space represents some bundle of different commodities, or to be a little more basic English, goods. Okay, every point within the space is going to be, in this case, some connection of or some combination of two goods, movies, and meals. Okay, to talk about the utility function, that's going to tell us how much value the consumer places on these various bundles that I've now labeled A, B, and C. Okay, you'll probably remember from high school, you can talk about a function of, say, one variable. For example, let's say we just wanted to talk about the utility that the consumer could get from watching movies and not concerned about any other goods. Now, we just say movies are on the horizontal axis with the utility function represented as a curve drawn above the axis. And the function of the curve is just simply to show us, we go upwards from the point A, we'll get the utility of A movies. Same for B. And if the consumer watches C movies, his utility U of C is going to be shown on the function like that. That's just very basic. Okay, now presently though, we need to worry about functions of two variables. So our graph's going to get a little bit more complicated. We can't use a curve function like we saw with before. We're going to have to use a geometric surface. So to show that, we're going to take the drawing that we have here and lay it flat. And then we can show the utility function as a surface, kind of a ceiling suspended above it. It works just the same way that the utility function that we had before does. You can start with a point down here instead of on the line, but on the plane, and go up to the surface, and it'll give you the utility that he gets for that point. Okay, so point A, you go straight up from that and hit the surface, and you'll see that you get utility U of A measured there. Okay, that works conceptually pretty well, but it's kind of hard with a mesh like this, kind of hard to deal with. Notice that we've got a hill, and this hill is also color-coded as to how high you are on the hill. Okay, one way that we talk about hills is with a topographic map. And that's exactly what we're going to be able to do with the utility function. Okay, so we're going to take the drawing that we've had before and flip it back up so we're looking straight down from on top. And we can do another representation of the utility function as a contour map. You know, you've all been hiking. You've all seen contour maps like that. Okay. So these contours are going to tell you how high you are on the hill. And just by seeing where it is, you know that A is lower than B and C is higher. Okay, so for any given contour, what we call an indifference curve, any point that is above the curve, that is to the right and above, is going to have higher utility than any point on the curve. So the curve itself, just like it would be for a topographic map, is a set of points or set of locations where the utility, or the elevation if it was a topo map, is some constant. So we have, say, the point B here, and every point on the curve that we've drawn is going to be some combination of meals and movies, which provides the same utility as does point B. If it provides the same utility, what that really means is the consumer is indifferent between one bundle than the other. He likes one just as well as he likes the other. Hence the term indifference curve. Okay, so we know that for any given indifference curve, any point to the right and above that curve is going to be preferred or correspond to higher utility, whereas any point below and to the left is going to correspond to lower utility. Okay, and we can take another, draw another utility curve, or another indifference curve rather, through C, and as we'll see here, the utility of every point on this curve is some other constant larger than the constant which represents this curve down here. Okay, there are a couple of important properties of these curves you need to be aware of, and they should be pretty obvious. The first one's pretty obvious now, and the need for the second one will come fairly shortly. But first of all, it's fairly obvious these curves never touch each other. They never cross. That wouldn't make any sense, because if it were a hill, that would mean that for the point where the two curves crossed, you'd have two different elevations. I suppose it could happen if you had a sharp cliff. And it's really better to say, well, at a point where you've got a cliff, the curves are just really close together. But they can certainly never cross. The other property that they have to have is convexity. They always have to be bowed or bulged towards the origin like we see down here. Now technically, a way that you can tell that a curve is convex is you can just take any 2 points on that curve, draw a line between them, and the rest of the line between the points has to be inside the curve, or above and to the right, just like I've shown here. Okay, there's another example. Other than that, though, the curve is fairly amorphous as long as it bulges in the right way. Sort of like what Mr. Bannon can demonstrate for us when a three-dimensional example. Yeah, there's the stuff. Okay, next we're going to talk about the budget constraint, and here we're going to be talking about the amount of money that it would take to buy any different quantity that's in here. So let's say we're starting off with a consumer who has some budget of money that we're going to call M. So if we were to take M and divide that by the price of the movies, that's going to give us how many movies he could buy with that quantity M. Same thing for meals. Divide M by the total number of meals, and that's going to give you the total number of meals that he could buy if he chose to spend all of his money on that. Okay, a straight line between those 2 points is going to give us all the combinations of movies and meals which he could just afford with his budget M. Below the straight line, we have the consumer's choice set. And given his budget M, he could purchase any quantity of goods represented by a point in this light blue area here. Okay. Of more interest, of a great deal of interest to us, is going to be how this line will represent the ratio of the prices of, say, movies for meals. Okay? So we're going to take a look at the rise and the run of this line here, which is the slope, but it gets a little bit more complicated than that. We'll notice that the rise, the vertical axis representing meals, this rise is going to be measured in terms of money divided by meals, whereas the run, or the horizontal, is going to be M divided by movies. Okay, so we're looking at the ratio of M over movies to M over meals. So when we actually take the ratios, what we're going to find is, we're going to wind up switching them. So in this case, the run is going to be, we're going to give the rise, or the run over the rise, in this case, is going to give you meals to movies. So it's just backwards of the axes here. Okay, well, let's see what happens. Let's say we were going to raise the price of movies. And as we can see that when the price of movies goes up, the budget line shifts inward to the left and becomes steeper. Okay, that's kind of counterintuitive, because we're going to think of when prices go up, you can buy less of the good. That's why that works that way. And when the price increases back or decreases back to where it was, the budget constraint flattens out again. Okay, so when we put the two lines together, we're going to see that this choice set, what we're going to try to do, what the consumer is going to want to do, is choose whichever bundle in this choice set is going to give him the greatest amount of value. Okay? And that's going to be the highest utility curve, or the highest indifference curve, that this budget constraint hits. And that's going to be right here. Okay? So at this point, we have the optimal choice, which is going to be the one bundle in this case that gives him the greatest amount of value or utility that he can get as a function of what he can afford. Okay, so that's the basics that we have here. Okay, so now we want to look at what happens when we start changing these relative prices. Okay? So we're going to start off here and look at what happens to the consumer's ability to buy goods if the price for movies increases. So just as we saw before, the constraint will shift to the left and give him a smaller choice set. Okay? We're going to see the red area is going to be all the bundles that he can no longer afford because the price of one of the two goods has gone up. What that means is he's got less funds to spend on either of the two goods together. And sure enough, the optimal bundle that he had before is no longer affordable. So his new optimal choice is going to be on a lower indifference curve. So this fact, or this fact that raising the price of either of the goods is basically going to reduce his utility because it's going to reduce his income, we're going to call the income effect. Okay? Another effect that we're going to notice here is that the new point that he can buy is going to contain more of whichever good was relatively cheaper than it was before. Let's just do the opposite case. Let's take a look now at what happens if we decrease the price for movies. And sure enough, the budget constraint will shift outward to the right, and that will make more bundles available to him. He'll be able to afford to buy more because his money's going to go a little farther. Okay, this is also an example of an income effect, okay, of the effect of the price change. We also will note that, yes, it puts him on a higher indifference curve because there is more goods he can afford. He is also still going to consume more of whichever good is going to be less expensive. So the fact that he is going to buy more of whichever good has become relatively cheaper because of the price change is going to be what we call the substitution effect. And it's always going to work that way. Okay. Now we want to be able to quantify, particularly when it comes to policy issues, we want to be able to quantify how much of this price change is going to affect the consumer's income versus how much is it going to shift how much the person buys of one good versus another, simply because one is now relatively more or less expensive with respect to the other than it was before. Okay, so what we'd like to do now is say that we're going to change the price and we're going to separate the income effect or measure it separately from the substitution effect. Okay, so to do that, what we're going to do is we're going to measure at the, say this is the, okay, we have gone from the old price to a new price which is lower for movies. Okay, now we're going to say take away from the consumer the extra amount of buying power that he got because the movies are relatively cheaper. Okay, so at the newer prices, okay, he can buy more of meals and movies than he could before, but we're going to take that extra buying power away from him by shifting the budget constraint down so that it touches the lower indifference curve on which he was before. Okay, now, okay, so that takes away what it does. Now we want to look at just how much substitution between, say, meals and movies he would make if he didn't get any more buying power as a result of the decrease in the price of movies. So that the distance here marked by the red arrow will show us how much more what the actual substitution effect is going to be. Then when we shift back up to where we were before, and I will say, pardon the reversing of the curves. That's something that PowerPoint is doing that I have no control over. It's probably just because I changed the colors. Okay, but then we're going to see that he has now able to buy more. Okay, the movement from A star to B is going to be the extra that he can buy, the extra of both goods that he can buy strictly because of the income effect. Okay, now this is rather important when it comes to, it may sound like almost a nitpicking kind of distinction between two things, but it tends to come up where people don't expect it in discussions over policy. And Joseph Gruber is one of our better-known public economists has talked about this when we're talking about programs, particularly things like Medicaid. We tend to, on the, say, particularly on the more conservative side, will tend to argue only, or will tend to consider only the substitution effect and ignore the income effect. An argument might be that, okay, let's say that the steeper budget constraint that I'm tracing out here with a pointer, that is without a Medicaid subsidy. Well, let's say we're now going to subsidize it, and that is going to effectively lower the price of health care and bring us out to this newer one. What that will do is cause the consumer, the substitution effect will cause the consumer to simply consume more health care because it's now relatively cheaper. And you'll find all kinds of arguments that what this is inefficient. Because we are making health care relatively cheaper, people are going to consume more than an efficient amount of it. But that argument's false. The real goal of a program like Medicaid has to do with the income effect. The fact that because healthcare now is relatively less expensive, people can afford to consume more meals and healthcare. In practical terms, what this means is people can afford to consume more health care without having to sacrifice meals. In other words, they're going to have better health care and better nutrition. And the ultimate goal is so that people will consume more of both, and that will cause them to be diagnosed for diseases more rapidly before the diseases become too expensive to treat. And that's become a real problem in poor areas where there has been little or no subsidy for Medicaid. Okay, so that's what that's about. And we need to be very careful in considering these two things when we talk about policy. Another policy example to look at is Citizens Climate Lobby's carbon and tax dividend. Now, what they would like to do, the first part of it, is to place a tax on fossil fuels at the point where they are extracted. Okay? And obviously what that's going to do is make fossil fuels relatively more expensive. But the tax is going to have another bad side. When the tax is applied to fossil fuels, what it's going to do is make people able to consume relatively less of both. So people in general will be on a lower indifference curve because there will be less energy to consume at any point. So certainly, yeah, we're going to have the issue where we're going to be consuming more renewable energy, but there will be a social cost caused by the tax itself. Okay, and of course this is assuming that the tax itself doesn't provide public goods. Okay, well, let's take that example in, and let's say, as what CCL wants to do, is they want to take that tax revenue and give it back to the consumer at the end of the year. So what this will do is get rid of this negative income effect. So let's see how that works. Okay, so we'll move our budget constraint back to where it was before we applied the tax. And now we're going to take the amount of money away from the consumer to put him, just to measure the income effect. We're going to slide that budget constraint back down so that it is on the same indifference curve that it was before, that it was when the tax was applied. And we'll be able to see here, where my pointer is, where the substitution effect is separated from the income effect. Okay, now what we want to do is then rotate the budget constraint so now it takes into account the relative difference in prices caused by the tax and is still on the same lower indifference curve. Okay, so this shows on this one just the raw substitution effect by itself. Now, if we can refund to the consumer all the money that the tax has cost him, that is going to shift the budget constraint back to where it was before. So now you're back on the same indifference curve, but you're consuming relatively less fossil fuel and more renewable energy with no loss on the economy.